Skill 9, Inductive and Deductive Reasoning. When we are trying to use reasoning to solve problems, we're going to use two different types, inductive and deductive. Inductive is when we just kind of use patterns of things we see and then say that something's going to happen. Deductive is a little bit more tricky, and we need to use different statements and then analyze what things look like, what other statements look like, to match them up to make a conclusion. So that's what we're going to do. For this first example, we're going to use the law of detachment to try to draw a conclusion from a set of statements. So if a ray divides an angle into two congruent angles, then the ray is an angle bisector. That's my first statement. Now, what has actually happened is ray RS divides angle ARB so that angle ARS is congruent to angle SRB. Okay, so when I'm looking at this, I see that my if statement is true in here because angle ARS is congruent to angle SRB. Because that is a true statement, and that's the if part of the statement, then that must mean that the then part is also true. So I can say that ray RS is an angle bisector of my angle ARB. For part B, it says if two angles are adjacent, then they share a common vertex. And then we have the second statement, angle 1 and angle 2 share a common vertex. So remember what we're looking for. We're looking for the if part to be true, and then if that is true, then we can assume the then part. So if two angles are adjacent, so we're trying to tell if they are adjacent, then we know they share a vertex. But here, we are told that the angles share a vertex, but we don't know if they're adjacent or not. So we can't actually make a conclusion. No conclusion can be made because we do not know that the angles are adjacent. And also, we could also come up with a counterexample. An example of a counterexample would be vertical angles. Vertical angles share a vertex, right? They share the vertex in the middle here. However, they are not adjacent. They don't have a common line, a common ray. So that means vertical angles would be a counterexample to this situation. In example 2, we're going to use the law of syllogism, which is a different way to reason out things using deductive reasoning. So what can we conclude from this information? If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure has 4 sides. You can think of the law of syllogism as, can you make a string of statements, if this, so that means this, and then you can kind of do a skip and say if the first thing, then the last thing. So what I mean by that is we have if a figure is a square. Okay, so if we assume that a figure is a square, then we can say it is a rectangle. But then we take another step and say, well, we know it's a rectangle. So if it's a rectangle, then we know it has 4 sides. So we can skip things and we can go right from a figure is a square, the figure has 4 sides. So what we're going to look at is our conclusion being, if a figure is a square, then the figure has 4 sides. We just made a string of ifs that are all true, and then we can make our conclusion, our then statement. For this next one, if you do gymnastics, then you are flexible. Next statement, if you do ballet, then you are flexible. Now on this one, we see that we have, if you do gymnastics, then you are flexible. Okay, so that That's an if-then statement, which is fine. But the next part that we know is if you do ballet. We don't know about what happens if you are flexible. We just know another thing that means you are flexible. Because if you do ballet, then you are flexible. So there's no way you can mix and match and make a string of things that all match up. So in this case, no conclusion can be made because neither of the conclusions is the hypothesis of the other statement. So we can't actually say anything about these statements. For this last one, we want to put a couple things together. We want to put both the law of syllogism and detachment together, which means you're going to have a few extra statements and you want to draw a special conclusion from the statements. If you live in Primgar, then you live in Iowa. If you live in Iowa, then you live in the United States of America. Okay, so with the law of syllogism, we could say, if you live in Primgar, then you live in the United States of America. That's the first thing we could say just using the law of syllogism right here. If you live in Primgar, then you live in the United States of America. You could do the skipping of Iowa. However, we have an extra bit of information. We know that Sam lives in Primgar. Okay, well, if Sam lives in Primgar, then that means because we could skip and do those two, then Sam must live in the United States of America. So my conclusion to this set of statements is Sam lives in the United States of America. You could also say Sam lives in Iowa. Either one of those would have been true statements based on the law of detachment. Those are your notes over inductive and deductive reasoning. Go through, summarize, make sure you understand. If there's any questions, make sure you ask those. Go through some of your practice problems, and then you might be ready for your quiz over this material.